All right, thank you. I'm sure there'll be more people streaming back in as soon as they realize that they are going to be missing out on something really important. But as you can see from the UTM program, we have a full and very exciting agenda ahead of us. Now, the sessions this morning, as well as this afternoon, are focusing on UTM as a whole. So we'll be hearing from seven different speakers, and we will be having the session moderated by McCrorie. Again, I just wanted to go back and remind people that you can send in questions throughout the discussions, and Aaron will be able to look at them, and then later he may decide to ask if anybody wants to raise their hand as well. But the main thing is, as ideas come to you, go ahead and email them in to plenary@icao.int. So, to get going with this, I'd like to introduce Mr. McCrorie. He's Director General of Aviation Safety and Regulatory Framework at Transport Canada. He was appointed as one of two Directors General at Transport Canada in April of 2015, after leading a number of regulatory programs in the area of surface security, security for major special events, aviation security, and most recently, aviation safety. Now, unfortunately, our second moderator that's shown on the program, Parimal Kopardekar, otherwise known as PK, is unable to join us today or tomorrow. So all of this will be in the fine hands of Aaron. Please.
Thank you, Leslie. You know, I always say it's a pleasure to be here, but it's actually really exciting to be here today. And I was thinking about how I wanted to introduce this session. And I've had the privilege, the honor of attending very many different sessions where we've talked about drones or UAVs, speaking at them, attending them. And today, for the first time, I've actually heard a different tone, a new and a different tone to how people are talking about it. There's an optimism, there's a curiosity, there's an openness. And so I can't help but think that this is kind of what I'd like to think. I'm a student of history. I love to think about history and read about history. And I can't help but think that this curiosity, this openness is in fact, in some respects, the same spirit that originally propelled us into the air in the first place. I often find the discussions around UAVs to be an either or, and we talk about it being a disruptive technology. But remember, at one point in time, an airplane was a disruptive technology. Aviation has always been an industry of innovation. It's always been disruptive. From the first dreams of flight, to balloons, to fixed-wing aircraft, to helicopters, space travel, and now to unmanned systems. Every day we're seeing how UASs are creating social, economic, and safety benefits. And I heard the term, we've used this term before, the democratization of airspace. But again, arguably, it might actually in fact be the re-democratization of airspace. So our challenge is to continue in that original spirit of openness, that original curiosity that drove the development of the aviation industry, that all of our opening speakers spoke to this morning, to embrace and promote change. It's in that spirit that I'm particularly excited to be here to hear today from our panel members. The session this morning will provide, and this afternoon will provide, an opportunity to showcase several submissions from experts that describe a common framework for UTM that could be implemented by all states. The objective is to create a structure that will focus research and development activities going forward. We're going to have 25 minutes allotted for each speaker, and my primary task is to watch the clock. Their primary task is to educate us. The discussion period will be at the end of our second UTM session. So presentations only this morning, and then another round of presentations this afternoon, and then questions at the end of that. But please, as Leslie mentioned, please send your questions in throughout the day. As you hear from these folks today, send your questions in, and we'll sort through them. We'll try to get to as many of them as we can this afternoon. So we'll have a second session after lunch. And again, PK sends his regrets, and I think the really important thing is to hear from these gentlemen. So first, I'm going to introduce Mr. Ben Talley, the co-founder and CIO of the GeoNetwork. Ben is co-founder and CEO of the technology startup GeoNetwork, the geofencing company. He is an inventor with multiple patents, an entrepreneur, a pilot, and an aircraft owner, manufacturer, and repairman. He has an extensive background in network engineering, security, and software development. So welcome, Ben.
Thank you, Aaron. And thank you to everyone at ICAO and the advisory group that made it possible for me to be here. Get my notes out here. Okay. I have a large slide deck, so I'm just going to power right through this. This is great. So all of the technologies that I'm going to be presenting today are brought to us by Internet standards groups, IEEE, ICANN, and what's that?
Put the microphone away.
Oh, is that better? Oh, sorry about that. So I'm going to start with ID and tracking, which is sort of in the middle. Could you play the video? So what we're seeing here is video recorded from ForeFlight, which is a popular electronic flight bag software used in manned aviation for flight planning and situational awareness with portable avionics, including ADS-B. So what we're seeing here is an airliner landing on runway 7 left at McCrorie in Las Vegas. And on a perpendicular approach to the airport is a drone at ground level. All of the UAS that you're seeing in the video and in the coming slides are real UAS that are UAVs that are being ferried around sensitive areas on general aviation aircraft and ground vehicles. Here's an example of a collision alert in ForeFlight that was detected between an airliner circled in blue and another drone at ground level circled in red. This is a situation in a less congested area where we're simulating law enforcement or a private citizen collecting a UAS ID with their own mobile device. So let's talk about how we did that exactly. This was achieved with no additional hardware, no hardware modification, and no internet connection. This was done with technology that's in your pocket right now. This looks familiar to most of us. All of these elements that you see on the screen are delivered to your phone using this technology, which is a Wi-Fi beacon. These beacons are don't require a connection. They're being emitted by every Wi-Fi device all the time. So based on the occupancy of this room and the assumption that each of you has at least one Wi-Fi device with you, we're emitting about 5,000 beacons per second. So again, this is a one-way broadcast, doesn't require a connection. This is fundamental to every Wi-Fi chip. It's been there since the beginning of the Wi-Fi specification in the mid-90s. It's a continuous process. Beacons are being emitted by the Wi-Fi chip, regardless of what you're doing with your Wi-Fi device. So whether you're connected to a network or not, you could be downloading media in the case of a UAV, or uploading firmware, streaming FPV video, it continues to beacon. So industry experts tell us that Wi-Fi beacons can be received at a range of 3 to 5 times the distance needed to make a Wi-Fi connection or an association. In our independent testing in the Nevada desert, we've achieved ranges of 12 to 15 times that range. So there's a clever way to embed fields, much like we do with ADS-B, in beacons. This is a practice that's well known There are lots of academic papers out there and standards within the IEEE that tell us how to achieve this. We simply place data in the lowest level of the chip, and it does the rest of the work for us. So we're beaconing out things like ID, location, and various UAS capabilities. So the first thing that we did was implement garden variety ADS-B over beacon stuffing. That works great, but the fields of ADS-B aren't quite adequate for UAS. So we recommend a new protocol, MBSB, the multiband spatial broadcast, which embeds more efficient 3D encoding of position, more precise, and 3D at its core with much higher precision. We're also more efficiently encoding the UAS capabilities and state. Those include things like the launch location of the device, its battery endurance, the C2 link state, whether it's in return to home, and whether its camera is currently recording. The receivers are inexpensive and come in a variety of sizes. Antennas range from the one on your mobile phone to a tower for a variety of applications. So we, in terms of readiness, we have this running right now. We have ADS-B and MBSB beaconing concurrently, and we're giving this to the world. It's in our GitHub repository. We'll get that information will go out with the slides that are distributed after the event. This has been adopted by a counter UAS partner who is shipping drones with MBSB beacons on them to use as a friendly force application to differentiate their own drones from others. This is very low friction for an OEM that has a Wi-Fi chip on board, which many do. This is just software, so in terms of size, weight, and power, the size and weight is 0, and the power budget is actually improved because we turned the beaconing rate down from the default. In our initial testing, we're getting 18 kilometers in the Nevada desert with high gain antennas. This solution is standards-based. It's working and available to you, and it's extensible. Okay, moving on to UAS registry, and we did respond to all 3 points, so a pretty dense slide deck. So if we believe that a registration is required, the obvious question is, where will we put it? And I know I'm not the first to recommend this, but please consider DNS. It's often referred to as the telephone directory of the internet. Its purpose is to bind names, numbers, and services on the internet to each other. This is a technology that's been in place since 1985, has processes in place to address security, privacy, and sovereignty. So let's have a look at one of these registration URLs. And this is a URL. You could paste this into a browser or use it with other services. This first bit of the number is the license plate or serial number. Could be a VIN. We haven't decided what to do with that exactly, but we do think it should be distributed by an organization like ICAO in much the same way that IEEE distributes Wi-Fi chips and Bluetooth chips. The second field is indicates which state this registration was made in. This is the ISO code for each of the individual states. And the last 2 fields represent the domain on the internet where this registry resides. So this is a quick look at the flow of a registration. The registrant sends the registration to their CAA, who acts as a UAS registrar. That makes its way into the global DNS infrastructure, where it is in turn consumed by service providers and other stakeholders directly over DNS. One of the important features of DNS is that it has its own local caching mechanism. So as you transition from one network to another, the records persist in memory, even while you're disconnected. So it's extremely tolerant to intermittent connectivity. So again, this solution is standards-based. It's working and available to you. It is on the ultimate scalable infrastructure, the core of the internet, and has these processes in place to protect privacy and sovereignty. So my final and favorite topic, geofencing. Most implementations of geofencing are pretty crude, simply fly, no-fly areas. We need smarter geofences. We need geofences that both enable and restrict, with entitlements like altitude, whether your camera can record in a place, what weight is allowed if you're going to transit a space, battery endurance that's required to enter or transit a space, time of day restrictions, equipage. This is two examples of UAS with geofences and rules on board. For UAS 1, it has rules and an authorization that allow it to enter this particular fence, or does not allow it to enter this fence. So using a software agent, it's restricted from entering this space regardless of the intentions of its operator. In the second case, this is a police-operated UAS, which does have an authorization on board and, of course, can transit this space, but all the while using the previous beaconing technology, alerting everyone around it that it is operating under that authorization. So this is a very simplified snapshot of the ecosystem today. So CAAs are defining airspace and rules. UAS manufacturers are creating the UAS and its capabilities, and we hope that the UAS pilot is following the rules. And civil society trusts that UTM is under control. There are a few warts with this assumption. Civil society has more problems in their communities than we thought. And would like to see more rules at the local level. The UAS can only follow the rules, UAS operator can only follow rules that they understand. And the manufacturer is getting conflicting messages from CAAs and from their customers and local authorities. And of course, it falls back on the CAA to manage this mess. So we're going to come back to this slide in a moment. So we're all familiar with this process, a 28-day cycle for the publication of airspace. Service providers consume that 28-day cycle through integrations, create data products, which they in turn distribute to their stakeholders. When we introduce a geofence registry, a smart fence registry, the same publication process begins with the CAA, but a copy of this makes its way into DNS and is enriched with the rules of the space that makes it suitable for consumption in autonomous systems to allow UAS and companion computers, other systems that control airspace to provide autonomous compliance. This doesn't affect the normal consumption of airspace by service providers and the services that they provide. Okay. Why micro airspace? By their very nature, UAS are capable of being more invasive in our everyday lives than manned aircraft. And we can all point to an example of a neighborhood-level conflict that might be best handled by local authorities. Communities want a voice in rulemaking at these lower altitudes of UTM, something that we refer to as micro airspace. Local knowledge, whoops, those ran off. Local knowledge and community participation are critical aspects of micro airspace management. Something's happened here. Okay. So let's take a look at a local life cycle of micro airspace. So we'll meet the mayor of town here. He would like to set some rules for treetop level airspace in the town square. He selects an area from a set of registered parcels, applies some rules to that space. So today he's going to enable FPV operation. And then he goes through a process that has 3 steps. It is published to DNS. DNS delivers it specifically to the region that it covers, and the UAS autonomously comply. This is a system that we've had deployed quietly since the summer of 2016. The only thing that's required is for a software agent to be integrated into the firmware of the UAS, and we've demonstrated this on the 3 leading consumer UAVs. So let's take another look at this slide with micro airspace. We have a new actor here. The drone follows rules independently. The CAA still defines space and provides tools to local authorities to do the same. The UAS manufacturer has some pressure taken off of them by allowing the software agent to provide compliance with the rules from the CAA. UAS pilot can follow the rules much more easily because they get feedback from the UAV as it complies with the rules that have been set. And civil society trusts that UTM is under control because they can set local rules and see the results immediately themselves. This is also standards-based, and it's functioning, and is extensible. So I have one last thing. There was one thing missing in our slide deck here, which was the communication and a collision avoidance aspect. If we combine the beacon with the geofence, we get a smart bumper around the device that can be used to provide sequencing and spacing in airways and clear the path, especially for local law enforcement applications. Thank you.
Thank you, Ben. I'd now like to invite Dr. Loh. I'm going to apologize. I'm terrible with pronunciation, so I'm going to start with apologizing right off the bat. Dr. Loh Keen Huat, the Principal Investigator for the Air Traffic Management Research Institute. Dr. Loh is currently a professor in the School of Mechanical and Aerospace Engineering at Nanyang Technological University in Singapore. His areas of research include robotics, vibrations, impact analysis, dynamics and control, machine and mechanism design. He is currently leading a research program in traffic management of unmanned aircraft systems, particularly for operations in urban areas. So,
which one I should press?
I think forward is that one. Yeah.
Good morning, everybody. Now it's midnight in Singapore. It's the time I should sleep. Yeah, first of all, I'd like to thank, just I hear from Leslie mentioned about how difficult we are selected to present our work here. I find that for so many years as a professor, it's even tougher than to submit to a top journal. So I'm very happy to be here. Yeah, they have done a good job. So once again, thanks UAS advisory group to allow us to present our work here. And this program is basically the idea of the UTM, the proposal, the 4-person thought about this about 2 years ago. And in Singapore, we take about 1 year. Finally, the work start 1 year ago. And I realized it. I'm one of the, I may be the only one in this, from academic, in this plenary session. Plenary session. So I just want to ensure you, doesn't mean that I'm the professor. The thing is not too academic. In fact, it's quite relevant. We achieved for this project. I have been working for more than 30 projects in my life. This is the one tougher, but it's more interesting. And we work with many different partners, different industries. So even the funding agent always keep talking to us to make sure that the program is relevant. So this today, the work that I present is for so many months we work with the collaborate here. Collaborators here, AGI, M1, and NOVA. Actually, they serve different purpose. Like M1, M1 is one of the local telecom company. To have that involved is make a lot of sense for this to do C2 communication. And for today's slide, you can see it's totally like you go back to your university time. It's a totally academic presentation. And initially, the first version I have about two weeks ago, 40 pages, 40 slides. Actually, this is version 8, now it's become 25. It's still quite tough. 25 slides in 25 minutes. I have several videos to show you. And I feel that a picture is worth 1,000 words, and a video is worth actually 1,000 pictures. So I will try to do my job to actually control the time. And there's a lot of detail I may skip. I just want to show, I love to show, because I'm a professor, I love to show that the work we had done. So if anything, the detail want to discuss, even you want my presentation slide, I can send it to you free of charge in the first time, all right? So maybe we work for that. Okay, quickly mention that the agenda today will be talking about introduction, and motivation is important. Whatever you do, you must have a purpose. You must have purpose to do that. And also, I like to talk about the signature. It's very important. And you look at my title, I'm talking about urban, and different from many other UTM that you have now. Why I need to talk about urban, I will mention the reason to you. And I would like to talk about the framework we propose. It's a concept, but very soon we need to implement. This morning's speaker talking about Singapore is going to implement UTM. I was so nervous. Hopefully it's not me, yeah. And then I will show the Singapore case study, a quick job, talk about the proof of concept overall, talk about CC2, talk about DAA and geofencing. So I will make some summary. Okay, so introduction is the purpose of this today's talk is actually to define, to show you the word, to define a framework for urban traffic management system. And you can see I add a small U there to differentiate the capital U. And the system will be operate on unmanned system effectively, safely, and effectively. I always feel that safety is a top priority. And you can see the image diagram talk about urban. And then now you talk about motivation here. And this one I don't need to mention to you, the growing demands for UAS operation by government agency, recreation, and commercial usage. I have been working in robotics for more than 30 years, so you can guess my age, right? But UAS is something that grows very fast. It's just, I talked to the first speaker, it's just go very fast that you cannot follow, you have to just do, all right? And the next good thing that I have, to be professor in Singapore, if you want to work hard, there's always a research money there. And Singapore is doing well, talking about the great initiative. And this is just come out recent, just 2 years ago, talk about smart city. In the smart city, you can see you may not see the diagram there, but it talk about drone, and you talk about future mobility. Future mobility actually cover unmanned system, including UAV. And one thing I need to tell you, Singapore is so-called garden city. And just tell you that how big is Singapore? It's a 720 square kilometer, all right? If we talk about Canada, US, Russian, China, it's 9.5 million square kilometer. You may not have idea on that. This morning I just checked, I only have 3 hours sleep. This morning I checked in Metro Islands, actually 500 square kilometers. And Singapore is top of population 6.5. So if you talk about urban, who will be have to do it? is Singapore, because according to the United Nations definition, urbanization, Singapore is score 100%. So when I do this project, they insist that I must talk about urban. So today our talk is more on the so-called, not so much on local, but talk about urban. Hopefully the work done eventually can apply to my friend, my researchers, the friend from Korea, for Tokyo, for all this so-called China. So this is something that I like to learn from that, like to share with that also. So quickly mention, this one I don't need to mention, spend too much time, you talk about application. But one thing you can see, this is a Singapore, beautiful town there. There is something like future. When I say, people ask me, how long you can see, you think that this thing will happen? Nobody can guess. It's a $100 million the question. But to Singapore, it's always ready to go for it. All right, so this is just a future idea. But again, I want to mention something. Safety is important. Come about the signature of Singapore urban infrastructure. And what we first do is, we come out of Singapore, so small island, we need to zoom. We have the different zone for the urban town in a small area. That is meant for efficient and effective management of drone operation. Because we understand different area, because different terrain, different condition, different application. All this cannot just one method suit all. You have to have a different consideration. And we actually also understand that we need to make sure that for the cost effective, you need to see an open area. But we also understand that we should have something called designated takeoff or landing. And we come out number is up to, the flying height is up to 200 feet. So far, that is a regulation set by the so-called policy body. And we also come out something called the distance between the takeoff and landing should be a distance, and we give a number 20 meters. So that is just now see the, I can see the retail area. Retail area means this is the area that you talk about designated supply and takeoff. And the next thing you see is landing. And the landing is the one that's resident area, and you're actually receiving your goods there. And we actually use a multi-car park. Singapore and Hong Kong, there's a lot of multi-story car park and top of open area. So you can see the diagram there. And the next thing, so I can play the video. So from the video, you can quickly see there will be a different color. It's a takeoff landing, all right? And it's over the island. It is a concept. You can actually have about 100 designated landing and takeoff. I still think that door-to-door service is still a long way to go. But we understand that talking about this designated landing, that means when your goods, whatever thing land at some point, the customer can pick up or somebody go and pick up. And we have a study talking about people don't mind to walk, to go 500 meters. Is it 500 meters? I can see here. 500 meters actually to pick up the goods. So that is something that the radius of service coverage. So the key requirement for urban UTM framework is definitely have to understand, you have to be flexible, dynamic, and optimized airspace management designated for urban. Come to urban, you cannot have so rigid. You need to actually cater for dynamics changing for some reason. And we talk about technology and risk management required and suitable for urban. And come to urban, risk management is even more crucial because a human, more human because of all this urban property is very expensive. And we need to have reliable system with essential function to ensure effective, safe, and efficient UAV operation. For example, the first speaker just now mentioned about all this technology. And this is very important. We spent a few months talk about this. You can see this definitely is a job by professor. Modular. It's a modular. You can see I have a chapter 1. For my chapter 1, it's a user interface. And my chapter 2 is a UTM-UAS function. Then we have under this UTM-UAS function, you have chapter 1.1, and then you have 3. You all talk about management. Later I would mention more about it. And we also have C2. And then we also have so-called module. And this is a good thing when it comes to modular system, different country, different application, you can add thing, you can actually remove something. Most important is the database. So all this, we are very proud of this, the first version of this modular UTM framework. So I can quickly show you what we have here so that you can see the work. And we even have a tactical and a strategy function meant for the UA operator, meant for the UTM operator. Important thing is cyber security. I read the news in UK, talk about America, they want to make sure that the cyber security proof, that means you cannot have people to hack the thing. So come to this UAS, in Singapore also have other program very particular about this so-called cyber security. And you look at our database, I will actually go to a detail to talk about this. And look at database, it's very important. Database, actually, we have the different color, talk about UA operator, talk about UTM operator, and we talk about tactical function and the strategy function, and even we talking about UTM, the registration, and ground-based, ground computation. All this, my colleagues in the computer science, they are very interested to do it. And the table here is the color. Different colors show different things. It's a lot of things inside there. For professor, we can write a lot of papers. Yeah. And now I come to this UTM in UAS. And then there's something that we are happy to introduce is air matrix. Because just now Aaron actually introduced that I'm the person in vibration. We like the matrix, we like others. So the matrix is something that you have a multi-layer, you can many different types. And matrix actually can cover many different air blocks. It's something like building. And this thing can change. Doesn't have to be rectangular, can be any shape. And we also talk about C2 management. And the top diagram at your right is talking about the rear testing. And last weekend, I just followed my team. We actually measure the signal with M1, 400 feet. We apply the permit. That's the first group in Singapore able to fly 400 feet to test the signal. And once we have signal, this is real data, we can put it in our so-called our planning. We have a whole Singapore island map. This is a video, I believe. Yep. So you can see the video actually show the signal. Is it strong? Is it, especially when we come to the building in the urban, in the downtown, it's very important that you need to know this area is not good to fly because the signal is too weak. And also the color shows something, and different time, this so-called color will change, just like the traffic in the Montreal, peak hours and off-peak hours is different. And urban airspace management is very important also. Depend on different timing, different zone. You may have layer, you may have freestyle. Later I will show you an animation video that we have. And below the diagram below is actually show the whole Singapore island, 700 square kilometer. I want to emphasize that this is what you see is a whole country, and then already there are big area, different area actually show about geofencing, the restricted area for some reason. So in fact, the UAV can fly in Singapore. The area is not a lot. That's why it's even more crucial to optimize the airspace by the proper traffic management. And this is very important. This is very important. You can see here, I'm talking about different color. I'm talking about the urban airspace management. When you come to urban, so-called traffic management, you have to talk about capacity. That means we actually based on the service area, the supply area to the surface area 1 and 2, and you are talking about downtown. And you have to actually look at if in future, if I allow how many the maximum capacity of UAV fly from A to B. So we have actually some calculation. Over here we based on constant velocity, but come to the so-called professor, come to research, we can always use something called computer to change our criteria. And the result will come out quite fast. And here you talk about the so-called the planning. I believe this is a video also. And you see this video, we actually come out with dynamic. This one is something that for the UTM operator, they will actually quickly realize that this route is safe or not, based on the terrain, based on the signal, based on the building situation. All this is real building in Singapore. It's a very outdated. And you actually have a air block. All this green color is air block. I'm not sure you can see from the back or not, because it's quite far, but and if you want the video, free of charge, in version 1. Okay, you can see now it's a UAV will take off, and this is so-called well clear the sphere. It doesn't have to be sphere. It can be different, all kind of shape. If I use a potential field method, it doesn't have to be the so-called sphere size. Maybe I go to the next one. And the next thing is talking about tracking, talk about monitor system. We actually, all this is, that some meant for UTM, some meant for UA. The job here is actually, it's a middle block of a UTM UAS function. And the flight management, I don't want to go to Berlin there. This last mile delivery is good to show the video again. I love video, because I don't have time to see movie. You can see that you have a supply point, you have come out a different so-called landing and takeout, landing or takeoff. And this is something once you can dynamically arrange it. This is wonderful. This I need to tense AGI. Actually help us to come out this. This really, now this is exactly now in one of the busy town near the NTU. That is an MRT station. Is it still running there? You can see many UAV flying from A to B. Yep. And this is very important for urban. We need to be very careful, very actually concerned about this. It's a risk management and cybersecurity. For example, you have to understand the noise, understand privacy. You talk about human. There's a big group of people will be below the UAV. So for us, just 2 months ago, we conclude the study, UAV web threshold study, and we actually spend about 5 months time. We have experiment with theory. We actually have testing to show that what is the weight, what is the height threshold for safe UAV operation. So something like this, a university can do it on and off. Cybersecurity, basically you can see many things involved on that also. Singapore case study, video. Yep. This something used to be 10 minutes. This morning I cut it to 2.4. So next time allow me to a 1 hour speed. Tough, really. In my life, I never have a speed less than 20 minutes. Okay, you have a flight, and then you have a landing. This is actually meant for the, this is helped by the NOVA system, by the way. You actually key in I can't see from there. You key in the pilot and whatever purpose, and you actually select the designated so-called takeoff point. And you go to the landing also, and you go to the time. I don't know why NOVA actually they want to choose 12 o'clock, and they change to PM, and then now the sending request out. And this is a UTM operator. After they receive the request, they actually the route will be planned, and GUFI will be assigned, and then they will actually do all kind of this is actually online calculation, has to be very fast. So they talk about 3D infrastructure, and we for the time being we use a MATLAB to do it, and they talk about navigation, validation, talking about the signal coverage, and there's a lot of things behind it. And that is give you all this scientific, the measurement data, how safe it is. You see the green color is fine. So this is talk about navigation validation. All this is all do online. And airspace validation, is it airspace safe to fly? Is it any other UAV? And this one red color is not good because he passed through the non-fly zone. That's why it's a red color. So once you have all this, you actually check about terrain also. This is last thing we need to check. and talk about, and different town we have all this data, and this is talking about the building height, you have to go through it. And finally, it's approved. Then you need to have flight tracking. I'm sorry that this is something I can't do. We are supposed to have a multi-rotor UAV, but I did it last minute and no time to go and change it. And basically, this is a different color, different route. It's meant for different UAV. We can assume 100 UAV fly at one time, doing different job. And the so-called the pilot, the UA operator can also track their so-called the movement of their UAV. So this is a flight. They double confirm this after approval. And what I show you now is just one. It can be multiple, and we talk about multiple for commercial potential application. And you have a different color is landing and takeoff. Yep. Sure. And this is a thing that we just showed just on top of airspace. This is the thing I just showed about the aviation open house about 3 weeks ago. This gives you some idea of future. How future? How near? I don't know. You know better. All right. Future urban drone operation and airspace management. This is version 1. All right. Can I run it? And here you can see there's multiple UAV flying above a building, and this definitely is an urban setup. And you also have so-called UAS, virtual highway for interzone. That means for zone 1 to zone 2. And that is something that you can fly high. The one doing local activity is the other below. And then you have different color. You have detect and avoidance. You have geofencing also. So this is something which is a proof of concept, but eventually we need to implement it. There's a summary. There's a lot of things you can read if your English is good. All right. You actually talk about effectiveness, safety, and efficiency. All right, that means we have actually different thing, a modular framework to come out of thing to actually make sure that these 3 items has to be there. I need to put these 3 because I want the paper to be accepted by ICAO. So I have to follow that. Even my researcher tell me that the safety should not be the first because ICAO information, the request, the safety is the second. Yeah, no, this is order, just a killing. A further note. Just now we actually come out with a framework, and talking about framework is just a concept in the first version. Further revision required in technology and ComNof validation enhancement. There's a lot of work to do. And we are talking about research program, but many research programs in the world, but the one we have here, other than the DC2, DAA, all these are important. We emphasize urban traffic management, risk management, dynamic, because in urban had to be dynamic, and capacity planning. And this is a huge and complex program. That's why I need your help. We require more R&D. We need to talk to people here. That's why this platform is good. You have people from different background. And we need to understand each other. We need to learn from each other. So I will fly back to Singapore tomorrow night. You still have chance to talk to me if you want, all right? Thank you for your attention.
A minute to go.
A minute to go. Yeah, I have 1 minute to go. Can I sing a song? Thank you.
Maybe at lunch. Thank you, Dr. Loh. Just a reminder to send in your questions. We've got a couple questions coming in. They're good questions. We'd like to see some more of them. And now I'd like to introduce a duo. Mr. Alessandro Cardi is the Deputy Director for the Italian Civil Aviation Authority, and Mr. Cristiano Baldoni is the head of the CNS section at the Italian Air Navigation Service Provider, ENAV. After graduation in aeronautical engineering, Alessandro joined the Italian Civil Aviation Authority, where he worked for more than 35 years, covering almost all fields from airworthiness to aerodromes and airspace, holding different managerial positions. As head of the regulatory directorate, he was the author of the existing regulatory framework for drone operations, and today as the Vice Director General of ENAC, he is responsible for the UAS development program in Italy. His colleague Cristiano has a degree in aeronautical engineering, and after a few years with the European Space Agency, he joined ENAV, the Italian air navigation service provider, in 2002 at a management level. Recently, he was appointed as head of communication, navigation, surveillance, medio, and ICT security organizational unit. He's responsible for the implementation of ENAV's investment plan related to CNS and operational ground communication network infrastructure for ATM in Italy. So, gentlemen.
Ladies and gentlemen, good morning. It's really an honor to speak in front of you and trying to illustrate what we are doing or we're trying to do in Italy. This presentation is trying to offer a view of different points that, let's say, are interrelated in the field of UTM. UTM, for sure, is something that is related to technological issues, technological research, and so on. But it's not only this. It's something related also to the expectation, to the system, to institutional matters, and how to, let's say, merge and leave the system grow in this new field. So, what has been, what we presented is the agenda of the presentation in 5 steps, and setting the scene, the Italian implementation and first achievements. Then I will pass the mic to Cristiano to conclude with the roadmap for future growth and the conclusion. So, what are the challenges we have? Again, has been touched in the previous symposium many times. This new field, this new product, has changed a lot our perception of the aviation activities, and has put many challenges. These are more or less the fields impacted by the advent of drones. We had a rapid growth of drones without proper regulation and dedicated supporting services. They impact airspace safety and reliability. We have, for example, each year at least twice per month occurrence reported by the pilots, commercial pilots, for near miss or under separation. And these are the only ones that we know because they have noticed. We don't know the ones they have not noticed. So it's a problem for the other airspace users. And we have, of course, problems of safety and perceived safety from the general public. So we have to address this. When we start with this, let's say, first step, we produced in 2013 a regulation. We tried to regulate only commercial services. And suddenly we discovered that our regulation was not proper because our first approach was from the, let's say, airworthiness and safety point of view. So we centered our attention to the drone itself, trying to not to control, but to envisage what are the features, safety features, in order to let them fly. So suddenly we stopped the market. We had to quickly change the regulation, and we revert to a new approach that is operation-centric, trying to identify what are the enablers in other fields, like the operations, the flight restriction, and so on. I will speak in just a few minutes about our regulation. Drones need to be safely accommodated, and this is the other side of the medal when we speak about safety and about the operations. We need it, and we need to establish a separation between these drones, we are speaking about small drones, and the manned aviation. So many issues to regulate and to provide the right sketch for the operators to work and to proceed. There are also been, and there are still, strong concerns about security and privacy. And there is the urgency to unlock the enormous potential promised by full exploitation of drone-based services. These two issues are contradicting themselves because we need to unlock the system, but also there are real issues towards the use of this, specifically in the urban areas, and we worked with the police in order to identify some requirements or conditions in order to allow operation, not to block, but to allow operations. It's just a case of someone are very simple, the high visibility jackets for the pilots in order to be recognized, the access to a database of Civil Aviation Authority from the police in order to have as much as possible information about this world, and basically, and overall the identification, so the e-identification in real time. At the end, and last but not, is not the last issue, is that innovative services, different from the ones we know today for the manned aviation, are to be deployed for this kind of operations. But these services, they have a cost, they must be put in place, and they must be economically and financially sustainable. So we have to provide also a system for this. We worked on the two fields, the regulatory fields, trying to set up a regulation able to provide room and clear condition, simple and clear condition for operators to work and to grow. Our regulatory framework is providing the condition to perform any operation in Italy, and we pointed out some geographic limitations for flying drones, the height, for example, the distance from people, and so on. Operating conditions for safe operation in visual line of sight, and they are linked with some rule of the air, let's say, for example, the continuous monitoring of the drone, the rule of putting down the drone, grounding it if other users of their space are in the same area, and so on. We also developed some, let's say, conditions to qualify pilots, remote pilots, because we think that in the field of visual line of sight and even the urban areas, and the role of the pilot is a central one because it has the safety in its hands. So the situational awareness, the capacity, and the competency of pilots they play a key role in the safety. Then we put also a process to recognize commercial operators. There are some, let's say, it's a very simple process. It's a declaration, basically. Only for some safety critical scenarios outside of the standard ones that we have introduced must be approved or authorized by the Civil Aviation Authority before they can use it. In all the other situations, either for safety critical scenario where they use the standardized conditions, or for the non-safety critical scenarios, they can fly through a simple declaration that is processed in real time, and just to identify who is the operator in order to track it and to have a recording for many reasons, for safety reasons, for security reasons, and don't forget also the fiscal reasons. We are not responsible for this, but in any country there are some also fiscal law, and I think that they produce commercial services they have to be obliged to follow. We introduced security provisions. I mentioned some of these before. The most important is the let's say one is the identification, the e-identification that we have discussed with the police. Also, the means to have let's say the tools for the enforcement. Another one is the capacity for the police to introduce a no-fly zone in a simple way without passing through the standard cycle for IRAC, and so on. All these are already embedded in the regulation. They are operative. We use every day. We also introduced in the regulation the technical and operation conditions, or let's say the provision to develop technical conditions to operate a drone in beyond line of sight, either for outside cities and inside cities. What we need now is what we need now is to develop an airspace and UAV traffic management, UTM. These are basically part of a program, and we are trying to follow strictly the development of CONOPS for this kind of operation, the development and deployment of the UTM as a key answer to the drone development and integration. Of course, I use the word in this context. Integration is more compatibility, because we are speaking about very low-level airspace, and the reason for this is that we have very crowded, very low-level operations by many operators: the police, the Air Force, the finance, the operators that use helicopters, for example, for emergency medical services, the firemen, and so on. So it's quite crowded. And then the implementation of the UTM concept in the Italian airspace. To do this, we go through a process of an approach, let's say not a global, but more wide approach to the subject. We participate in the international activities in order to gather and to share and to catch good ideas and standards and practices and so on. We started with a partnership with the Civil Aviation Authority, represented by ENAC, and the other partners. A collaborative environment to be built to launch BVLOS operations, and at the end, the development and deployment of the Italian UTM solutions. These are the precursors, or let's say the key points that we wish, or we have tracked in order to have an effective program. Yeah. What about the partnership? We started with a partnership. We developed an agreement between us and our national service provider, ENAV, in August last year, based on some fundamental considerations. One is one field for the agreement is the registration and identification. So these are functions that traditionally are put, even legally, put on the shoulder and the remit of the Civil Aviation Authority. So we have to do this. But drones are aircraft, but they are a new kind of aircraft. So we cannot use the traditional way, the nationality mark, the ICAO system, nationality mark and registration mark. There are so many, and that system is not useful for this. So we have to go through a new system, and much more powerful system because of the numbers and the rapidity in which they change. So we started with the idea to have a registration and the identification of the drones through a cooperation with the ENAV, based on consideration that any operation in beyond line of sight in some way are, let's say, based on the knowledge of what is the drone, where is the drone. So the data that we are obliged by law for our remit to provide the registration is also used, and the identification is also used by the service provider to provide a service. So the same registration and the same system for identification is used to fulfill the requirements of registration and to be the basis for the e-tracking and for the provision of services. So we have chosen this way, and we decided to have one common database with ENAV, and ENAV will take care of the let's say, operational procedures. The registration in Italy is made by via web, so it is an easy process, and can be done very quickly. We use today to issue a registration, a digital registration through the QR code. The second pillar of our agreement with ENAC is the establishment of a regulatory framework. So to work together in order to set up what are the CONOPS for this kind of operation. We reached a provisional draft CONOPS at the end of last year, and we are today, in this year, in the phase of starting with some experiments and some validation campaign of the CONOPS, and also of the concept and the condition, to understand and to identify the conditions to set a regulation in the near future, as soon as we are in the condition. ENAC is also committed to develop the infrastructure for the deployment. Very quickly, you go. I went back. Yes, thank you. So, the collaborative environment that we are building is not only based, of course, on the cooperation between the Civil Aviation Authority and the service provider, but we had a number of meetings and activities involving the operators in order to understand the needs, the mission profiles for each one. They are very completely different from one to another. And then we have started the campaign in order to validate for the different operators for search and rescue, the medicine transportation, environment, and so on. What are the first achievements of this program? There is a web portal available for the public in the so-called D-Flight, where any operator can register its own drone. They will receive the registration identification. These are through a QR code. So till now we have a digital static identification, not in flight, not yet. And now we are also developing the website in order to allocate a number of information, useful information. Our dream is that this site will be the site of drone users. In order to get any information they need to fly safely and legally. This D-Flight will also be open to the police in order to establish, not only to publish from our side the permanent or already known no-fly zone, but also to have a dynamic use of the site for any security or public order need from the police, in order to show to any user in real time if there are some restricted areas for a few hours or a few days, depending on the event. Then these are the first achievements, and I think that we will go on this, and I will leave the podium to Cristiano to continue.
Thank you, McCrorie, for hosting me and this event. Thank you, Ari, for presenting myself. Thank you, Alessandro, for giving me the floor. It's a very big honor for me to speak today in front of such a great audience. So, I take over from Alessandro and trying to expose to you what is our roadmap. As I said from Eric, I represent here the Italian air navigation service provider, and as such we realized quite early at the beginning of 2015 that there was a challenge due to the so-called drone invasions. A challenge, as any kind of challenge, it brings also opportunities, and we believe this opportunity was worth insight. So we started very soon to launch a business case to understand whether this was a real opportunity for us in terms also of business, beside our duty in response to the same challenges that Alessandro showed at the very beginning of our joint presentation. So, as a matter of fact, we launched the business case. The business case, as we'll say later, proved to be positive, and on such basis, we start drafting a plan. And on the end of the plan, we got a management decision, which brought us to start our negotiation with ENAC, for which the result is exactly the agreement that Alessandro told to you a few minutes before. The very first step, as Alessandro showed, was the deployment of a web portal for the registration and the static identification of drones, and we will see a little bit more of that. But in our plan, we took the very end of the movie. We depict the target architecture of our UTM system, and we draw back from the end point up to the starting point to set up our roadmap. And surprisingly, our roadmap resembles pretty much the roadmap which has been presented by the CESAR undertaking early this year, named U-Space Blueprint, which was presented jointly between CESAR, joint undertaking, and the European Commission in the ENAC, I think May this year. So our target architecture is encompassing the full scope of UTM services, from the very basic one, e-registration, electronic identification, and geofencing, which are part of the so-called U1 setting of the UTM/U-Space, as we used to call it in Europe, up to U4. And the U4 is here overlapped with our watermark, which we'll see later is our high-level architecture of the UTM, the way we see it. So, before going to the in-depth side of our architecture of the system, I would like to underline a few things about identification and electronic identification. I have to say I sympathize a lot with what Ben from GeoNetwork explained, because we really share the same vision. For us, the identification process should be a lean and straightforward process, without the involvement of any, let me say, third parties commodities such as a mobile communication network. It should be as easy as the process that we use to recognize a car. We write down the plate of the car which we are interested in. Now, it's pretty easy to do this when you have the drone in your hands, which is our static identification. It might be a little bit more complex when the drone is flying some hundred of meters far from you, or even kilometers far from you. Now, for the static part, we saw our registration portal will deliver to the operator that registers his drone a QR code, which is encoding, decode the unique identification code which is released by the D-Flight platform. The drone operator is requested to print the QR code and stitch to the frame of his UAS. Pretty simple, pretty straightforward. For the electronic identification part, we think we need something that is broadcasting the unique identification code in the surrounding space of the drone itself. And by very simple means, such as a smartphone, as Ben was showing us, any user that is interested in identifying the drone should be able to note down the identification code. So decode the identification code for the broadcasting signal. In some ways, we are very agnostic, let me say, on the way this process should be implemented. Once the identification code is noted down, at any time, the user, the third-party user or the policeman will be able to query the flight using the ID to query the portal and obtain the level of information is looking at. Of course, depending on the profile of the third-party users, the information details will change. If it is a private citizen, he will just know that the drone was entitled to fly there, and at that time, if he's a policeman, he will get the full record of the drone operator, including his address, his mail, his phone, and so on and so forth. Because we want to be, we are very concerned about privacy of both the drone operators, pilots, owners, and the third parties that is interested in identifying that drone. Okay, thank you to Alessandro for leaving me with a short time. I will try to get as fast as possible. Yes, this is our watermark. I think it's somehow in Gutma and in other environments, this picture is well known already because it's a couple of years that we are showing around. I just want to show that the fact that our UTM application is thought to cover the full set of services from pre-flight services such as the registration of operators and drones themselves, support to mission planning, validation of a mission planning, submission of mission planning, and notification if there's no need for a further approval process, or back office approval, and eventually negotiation for a mission amendment. In-flight services such as tracking, monitoring, and alerting in case of non-conformance, and of course a support and a system for conflict detection and alerting based on geofencing and geocaching concept. One very important point in our architecture, and you might see on the right and lower side, is what we call the UTM box. Now the UTM box is the airborne component, the endpoint of our UTM system. For us it's very important that this UTM box stays within the application borders, the application perimeters of our UTM. It's a key point in our architecture. Why we want to do this? Because the UTM box is really critical for our liability, for securing the cybersecurity built-in construction in our design. So it's a key that we maintain the full ownership of this component. In the future, of course, we might let drone producers to work through OEM or through standards to embed this component inside. But I think that to respond timely to the demand, the market demand, we need a UTM box ready to be delivered to the users to implement the critical electronic identification services and the tracking services. That's 2 minutes. Okay, very good. So as you will probably get this diagram for free, or for not for free eventually. It's a pity because I think that here is the real meat of our presentation, is a contextual diagram. It shows again the core, the central part of the UTM box. We do not want to find ourselves in few years' time in the same situation as ATM, where we are now trying with a lot of effort to integrate the airborne segment of ATM with the ground segment of ATM. We have a great opportunity, is a blank paper now, and we can draw our architecture at our best. The system is encompassing several different clients, a UTM app, which could replace in some cases the UTM box for electronic identification of small drones flying VLOS. Getting to the business case as anticipated is a positive business case. It is based, of course, on a number of assumptions and on the market forecast we had available at 2015. So there is a promise that on the basis and the assumption that there will be a set of regulated services and a set of non-regulated services which the UTM service provider will offer on the market, there will be a positive return of investment in between 3 and 5 years, depending on the actual growth of the market, especially with regard to BVLOS and autonomous flights. So how we are actually implementing our system? NSP doesn't have the whole set of competences and technologies and know-how to build such a complex IT platform. So we launched a public tender to set up public-private partnership with a selected industrial partner. The process is ongoing. It started in August 2016 with a pre-qualification. September the 14th was the due date for the proposals, the fixed proposals. So the evaluation process is just starting, and we hope to complete the process by the end of 2017. We will then incorporate a new company, which is a partnership between ENAV and the selected industrial partner. ENAV will retain the majority of shares because we believe that we need to gather the full control of this company, whereas the industrial partner will play the major role of technical supplier for the system. We get now to the conclusion. Sorry, I had to rush up a little bit. It's a pity, but of course we can meet at lunch, and you can ask me whatever you like to ask. For a conclusion, we do believe together, ENAV and ENAC, we recognize that UTM is a key element to answer the challenges of drones. We think that the institutions, states and the stakeholders need to work together in order to respond to the market and social demand, and to timely support the exploitation of drones and their potential benefits. We need to ensure safe and secure integration of drones in the airspace, and we need to identify, and that's what we answer with our roadmap, a financial sustainable framework to support all this. And I can conclude that factually ENAV and ENAC started together the development and the deployment of UTM in Italy. Thank you.
We gave you a few extra minutes, I'm sorry.
One of the great pleasures of being a moderator is having to interrupt really interesting presentations, so thank you. Thank you, Alessandro and Cristiano. So just our final speaker of the morning. Remember, we've got some more speakers this afternoon, but our final speaker of the morning is going to be Mr. Kerr Kimchi, the Vice President of Amazon Prime Air. Gur is the co-founder and vice president of Prime Air, Amazon's future drone delivery system designed to safely transport packages to customers in 30 minutes or less. In this role, Gur leads a growing team of aviation robotics, hardware, and software experts in the development of Prime Air vehicles, systems, and operations. So, welcome.
And I apologize, I'll have to connect our laptop here. Let's see that this works. Are we on? Excellent. Thank you. I appreciate the invitation to come and speak to you today. This actually is a personal favorite of mine. I grew up in an aviation family. Some of my father's first pictures that he loves embarrassing me, sending to my friends on social networks, is me sitting on his lap flying a plane. Spend most of my weekends building experimental planes, a Huat Long Easy, a Seawind 2000, which is actually a Canadian design. So I feel aviation sort of flows in my blood. At the same time, I grew up to be an engineer. And what I'm going to talk to you today about is how we merge the field of engineering, IT, robotics with the one of aerospace. I also find myself repeating something that I'd done once in my life. In the mid-90s, I was part of the working group in the ITUT and in the ITF that created voice over the internet. And we started in 95 when the internet became commercial, and by 2000, about 10%, if I remember the numbers correctly, of all international traffic was traveling over IP. 5 years, that's all it took. And I feel that the energy and interest that we're seeing today will potentially progress at the same rate. Most of the stuff we heard in the morning, which was fascinating, and I felt sort of excited by it, was about what we would like to see. What I would like to talk to you mostly today is about how we see it working. What is our vision to see it working? You heard about Amazon Prime Air, I assume. Please go to our website, look at the video. Nothing revolutionary in terms of the customer experience. They just want the stuff fast and efficiently and, of course, safely. The way we make it, of course, is interesting, flying drones. The #1 priority for our service is safety. And this is where the inspiration from traditional aviation is paramount. When you boarded the commercial flight to come here today, as the door closed and the aircraft departed, you were probably in the safest place you would ever be in your life. And I'd like you to think about that. That heritage of safety is something that is unsurpassed in any other domain. Aerospace is unique. And I would like, my mission is to make sure when you or any other customer orders from Parimal, you have the same feeling of safety. It's just as safe. That's our #1 priority. Our concept, we would like to make a system that is scalable, safe, efficient, and global from day one. There was a comment around drones being a local operating medium. We definitely are going to operate cross-country. When you think about the EU as one potential example, and there are many other examples like that, operating cross-border is a fundamental part of how you build scalable and efficient logistic networks. So let's, while urban environments are fascinating and local operations are important and we have to solve these issues, thinking about something that is global, cross-border from day one is important. We can create something new that works for everybody from day one. This is very important. Second part that I'll show you is how we're going to leverage, like many of you have spoken about, thank you for that, we can leverage existing technologies. Some of what we have to build requires invention. That's great. We have a lot of inventors in this industry. A lot of it can be leveraged from other domains, from robotics, from information technology, from internet, from telecommunications. And I'll provide some of these examples. Let me start with our architectural model. In my case, I'm Amazon. We build and we design and we assemble and we fabricate and we program and manufacture our own drones. We don't buy and we don't sell from anyone. My drones connect to my infrastructure, which I expect to operate. I'm not going to make your life complicated by asking you to operate my infrastructure. That's my responsibility. And of course, all the NSPs in the room have the right to audit me and see that I'm doing what I promised to do, and I maintain the safety case that you trusted with me. There may be other drones in airspace. Your drones, if you're an operator, will connect potentially, if that's your choice, to your infrastructure. These two infrastructure systems will connect and communicate with each other. Technically, in internet terms, this is called federation. There isn't a central authority that is required to operate the entire system. Very similar to how your email works today. Your email client sends to your email server, which then federates to the recipient's email server, which is then sent to the final email client to the recipient. There isn't a big mailbox router in the sky. There isn't a central authority that manages the messages. And that architectural pattern is important. It is scalable, it is robust, and we know it works. We don't have to prove this technology on something that we don't know it works. Aviation authorities, ANSPs, depends on the business model in each country, they're slightly different, have a key role to play. They must audit, they must certify, they must drive for compliance, they must set policies. Some of these policies are consistent. You shall not fly into an airport unless you are permitted to, unless you have certain equipage. Some of these policies are dynamic. They'll be updated in real time. There is a medevac helicopter that has to come down in this part of the city right now. All drones must depart. Being able to support both of these kind of policies, online and permanent, for the same system, same architecture, same set of protocols and data exchanges is very, very important to us. Finally, we see a role, and I got questions about this from a few European regulators, we see a critical role of application service providers who offer this kind of infrastructure as a service. Not everybody who operates a small system has the capabilities or the wish or the want to build their own infrastructure. I see that there's a space for people to operate these as services, and they'll make this whole infrastructure available to small players. If you're a real estate flyer that want to just go and focus on generating great imagery for real estate, you don't have to deploy the infrastructure. You can purchase it as a service, just like you purchase web services today as a service, or your email from a service provider. Finally, the drones have to be able to talk to each other. This is a key point. The system is safer when you have both strategic management of the drones and tactical management of the drones. This vehicle-to-vehicle communication concept was mentioned before, and it's very important, and we'll provide some examples of how that works. Notice the dissolve I just did. If I show you our vision for this architecture, and I replace the terminology with the one that we currently use today for telephone network, specifically the cellular network, the phone in your head, it's the same one. And if you go and look at a lot of other internet architectures, other telecom or banking or many email, many of these architectures, they use the same architecture, the same type of protocols. What we're proposing is something that we know works. It's been working and serving us for the last 25 years. Just like we can be inspired by aerospace and how to drive a safe system, we can be inspired by IT on how to drive a scalable and efficient system. Question I get often is, great, you're going to drive a lot of automation. What is the role of people when you have so much automation? Well, it actually turns out to be a really interesting question and something that we have a strong opinion on. The role of automation is to execute your policies. It's to enforce access control and also to detect exceptions. If someone isn't doing what they're allowed to do, the automation should catch it and notify the relevant authorities. It can be recorded, it can be audited, it is non-repudiated, and it's secure. Automation enables you to be more scalable. At the same time, people have an absolutely critical role to play that will remain essentially forever. They have to define these policies. There are great questions we heard on the role of local versus regional versus federal level regulations, interstate regulation, inter-country regulations. These will always be within the purview of people. They'll set these policies, and then the automation will execute these policies. And people always have the option of modifying these policies. And there are exceptions that are about the operations itself. Potentially there's a change in the flow that you need to, like a 28-day cycle, and you change the programming of the network, if you will. And also exceptions that are real-time. There may be a special event that happens from a police or law enforcement perspective that requires immediate attention. One of the things we stress in this architecture is no difference between online and offline. There is no difference in planning and replanning. They are the same thing. When you think about the way we manage the airspace today, we spend a huge amount of time planning, and then when something unexpected happens, whether an emergency or whatever, we have to then do emergency replanning. In this architecture, it's continuous replanning all the time. Thinking about this as an online optimization of the airspace. It also makes the airspace much more efficient. We get to utilize it in a better way. And if you have high utilization, the question of fairness and equal access becomes easier because you have much more capacity. This is a concept we borrowed, were inspired, stole, you pick the term that you choose from traditional aviation. I'm saying traditional in the most respectful and loving way. It is traditional so much that I trust it every day when I fly. The reason that I heard a lot of professional aviation people tell me why aerospace is so safe. It has layers of safety, and each of these layers support each other to make a safe system. At the top level, we have strategic safety and strategic airspace management through the role of ATC. And of course, I'm simplifying, you know this much better than I do. At the next layer down, between aircraft, we have systems such as TCAS and ADS-B, and the final level we have see and avoid with pilots. We're proposing a very similar architecture, but using slightly different technology, with, of course, a lot more automation. At the strategic layer, you have UTM, unmanned traffic management. At the tactical layer, between aircraft, you have vehicle-to-vehicle communications. Wi-Fi use is absolutely a great idea. We would also propose that we look at V2V technologies that are being deployed in active safety systems in automobiles today. The idea that you can have all our smart devices, all our robots, both the ones that are driven and the ones that are flying, be able to communicate, and it's basically just Wi-Fi 802.11p, is super interesting. If a drone actually has to declare emergency and perform an emergency landing, and think about the GA pilot that lands on a highway, that just, of course we don't want it to happen, but we know it's gonna happen. How about they could communicate with the cars and clear a lane. If these robots can talk to each other through standard means, standard protocols, we just created a safer environment for everybody. So this layered approach is where we get on. I just find my point. Another point here is detect and avoid. You heard there was a great question in a morning session, early morning session, I should say, on detect and avoid. I would proceed that detect and avoid is not only possible, but it's already here. We're just not deploying it. We've demonstrated to regulators around the world. The difference is how is that even possible, and after you do demonstrations like why aren't you deploying it? Again, the inspiration is from robotics. The inspiration is from self-driving cars. A lot of the technologies that we've developed as an industrial world can be leveraged for airplanes. And Brian mentioned that he wants autonomy on his plane and he wants the planes to help him. I completely agree. I have a little bit of autonomy in my car, and the fact that the car is actually avoiding cars around it, it's fantastic. We can make planes do the same thing. And does detect and avoid need to be better than see and avoid? Well, yes, absolutely. Not only because it needs to be, because we have to maintain everybody's trust, because it can be. Computers don't get tired. They can look all around them in 360 directions, 360. They can use sensors that see through the fog and through the rain and through the ice. They can do things that our eyes, which get tired and etc., just can't do. Detect and avoid will be better. And I'm not talking about 25 years in the future. I'm talking about the next 5 years, things that we can leverage, things we can deploy right now. Most of my presentation and talking points are going to be on the latter part of UTM, but authentication in the form of a drone registry is, of course, very, very important. We have people right here in the crowd who are part of my team who participate in a lot of this work. It's a big investment by Amazon. We believe that everybody who's in the air and everybody who's operating systems that are in the air, both the infrastructure that I mentioned and the drones themselves, cannot be anonymous. Just like we don't have anonymous cars and we don't have anonymous phones, we cannot have anonymous aircraft. I'll let it sit for a second, because I know for some people who come from my domain, that's a controversial statement. We introduced the role of a new network function. It's called UAC, an automated controller, a UAS automated controller. This is the implementation of that infrastructure that I showed you in some of the first architecture slides. This is simply no more and no less than an internet-connected service that runs these standard protocols. And again, I'll give you some example in a second. Because it's nothing more than a web service, of course, implemented securely and scalably and in a robust way. Our world knows how to do these things today. It can be affordable. I hear from a lot of you when I talk to more the appropriation side of the house that you're concerned that because there are going to be so many drones flying in the future, it'll become very expensive. In the back of your head, you're saying, if I have X planes flying today and it costs me Y to fund and operate, I'm going to have a very large X number of drones, and I multiply and I come out with crazy big numbers that I'll have to encumber my taxpayers with. The answer is no. We believe you can deploy this for a lot less. We know how to build safe, secure, but also affordable technology today. This is important. There is no financial barrier to deploy these things. And again, the never anonymous point that I made before. I think showing some example will be important. I think that this will sort of maybe crystallize what I'm talking about. And yes, videos are great. I have a few videos. They're potentially not as fancy as yours, but we'll start the discovery. So the concept of my infrastructure, my UAC controlling my drone, your infrastructure, your UAC controlling your drone, you, the ANSP, having your own overlay set of infrastructure that can look and see all the other UACs and get awareness, get notifications, set policies. That requires everybody to be able to discover each other. That's a fundamental capability. Yes, DNS can be a fundamental part of that capability. We'll start with an unnamed location. We started with some maps, and of course people get confused. So this is a fake location, a fake city somewhere in the world. And we have the authority UAC, which depends on the country, can be represented by the NSP, and they maintain a database. That database can of course be implemented using DNS or other, whatever is cheap and scalable and works for you. What you'll notice is a UAC, one of these automated controllers, the ones that manage their fleet of drones, go to the database and ask to see who they need to talk to. This is important because the first entity they'll have to communicate to and say, hey, I'd like to operate, is the authority. At this point, we only have one operator and one authority. They maintain a connection. This allows the operator to update the authority about things that are going on based on policies. Some authorities may require a lot of notifications, some of them not. That's a local policy decision. The next one to come is going to discover UAC1 and the authority, and is going to connect to both of them. Now, this is an important point. If you look on your left, you see a yellow box. That is the area of interest, or the area of operations, that is represented by UAC1. You'll also see a red box. That's the area of interest of area operations represented by UAC2. Because these areas of interest overlap, they not only register with the authority, they also register with each other. I'll let you think about that concept for a second. That's an important concept. Today, when you think about aerospace management, about ATC, I go from cell to cell. Here, the cells can overlap. This is very much like the way your phone works. Some of you may have Bell as your service provider. I don't actually know all the Canadian telephone providers. I'm sure there's more. Some of them will have a different cell provider. You're not hopping from one network, from one cell to the other, across networks. You each connect to your networks. These networks overlap and federate. That's done through discovery. Same principle, same architecture. Let's just, for the sake of the exercise, introduce UAC3. They're going to get the database of who else they should be registered to based on their area of interest. What they're actually submitting is an area. And in this case, because they overlap with the other two, they will also cross-register, cross-connect, and maintain a connection with everybody, including the authority, of course. And to complete the scenario, we introduce UAC4, and their area of interest is interesting. They don't overlap with anyone else. Maybe they're a local operator, and they operate somewhere outside. They do precision agriculture. There's nobody else. It's a private land, and that's all they do. And because they don't overlap with the other operators, they only register with the authority. Now, of course, the authority can change the database. That'll be refreshed by the UACs, and they'll cross-register. The UAC can say, I'd like to change my area of operations. I'd like to start to operate in a new location. Maybe I have to operate at 8 a.m. in this new location. They're going to now cross-register with everybody else the same way. It's a dynamic map. Okay, so now we have a set of operators, UACs, that are aware of each other, aware of their area of interest, and have a persistent connection between each other. When I say connection, I mean nothing more, nothing less than an internet connection. Obviously secure, obviously with quality of service, all the great capabilities that we've developed on the internet, and we don't always use them. I'll encourage us to use all these capabilities today. Okay. Let's do notifications. Of course, I'm the last one, and the only thing between you and me is lunch, so, you know. Exactly, right. What we're showing here is 4 drones. We picked a random picture of drones, operate on each of the area of interest. Now, in this specific example, you notice that the drones' missions, their trajectories, do not cross any of the overlapping areas. If you operate in an area that doesn't intersect with anyone else, you don't have to notify them. Of course, you may still notify the authority. You notice the authority is that big box around everybody. Again, based on the authorities' policies. They can decide to say, I'd like excuse me, I'd like to know about every single flight that's happening, or I'd like to know about exceptions, etc. Let's complicate the scenario a little bit. Let's actually create a mission, in this case from UAC2, that is going to traverse to an area that's overlapping, in this case UAC1. What UAC2 will do is, while they're preparing the mission, they'll send the route to UAC1. Now, because UAC1 knows about their missions and everybody that they control, and they recognize that there's no conflict, they're just going to say, okay, go ahead. Now, while the drone managed by UAC2 flies in the overlap area, they're going to send notifications. And it's not the drone, it's the UAC2 sending to UAC1 notifications about the status of that mission. That's important because if UAC1 wants to operate something, they need to know in real time what's going to happen in that area. Now, you notice the second principle of this architecture. It filters communication in a way that you only are aware of what you need to be aware of. It's not everybody broadcasting to everybody else. It's you only get alerted when you actually need to. You only get notifications when it actually matters, when there's an operational need for it. Let's do a more complex example where the missions actually potentially conflict. In this case, we have two drones from UAC1 and UAC2, and they know that these missions will cross into the overlapping area and they'll share the routes with each other. In this case, the routes happen to be conflicting. They conflict in X, Y, Z, or time. One of these was too close. What the trick here, and I'll maybe play it again just so it makes more sense. The trick here is they both share the route and they both have the same data. They'll run the same deconfliction algorithm and get the same results. NASA and other parties have been spending the last decade developing robust and reliable deconfliction algorithms, automated deconfliction algorithms. We can come together and specify one, just like we have done for TICAS, that everybody has to implement. If you take the same deterministic algorithm and feed it the same data, it's going to generate the same predictive results. In this case, the missions were deconflicted. There are new missions. This now without the issue. They get shared with each other again. And while they're flying, of course, in the area that is overlapping, they'll update each other around the state of the mission. And in this case, they can know that something went wrong if it did. Mm-hmm. Something about notifications. We heard a lot about the difference between an offline system and an online system. When we say online system, and this is a discussion we had with a lot of the people who drive NextGen, not necessarily just the US NextGen, but also the European Cesar project, etc. When we say real-time notifications, we mean things that are faster than 10 seconds, better than 10 seconds. When you make an update, when you have to notify, the information traverses all the players in a network, all your nodes of the network in less than 10 seconds. Your immediate question is, does that require dedicated spectrum? Does that require dedicated protocols? The answer is no. As long as you have LTE communications, the same one you have in your phones, that's completely appropriate. You don't actually have to trust us on this. We went and measured and collected a lot of data, all the way up to 2,000 feet, and we can share this data. We're happy to share this data with regulators to demonstrate that that technology is actually applicable for our use case. Let's talk about dynamic policy updates. This is the important one, if you will. Classic example, I sit on the drone advisory committee for the FAA, and the person that usually sits on my left runs the helicopter association, and they have a lot of viable concerns about how low altitude airspace will be integrated. In this case, maybe I'll play this again just so it makes more sense. In this case, the two missions are about to take place. And you notice the authority, which is just another UAC, but this UAC has superpowers. They can change the policies. They can change the policy for everybody. Issued a new no-fly zone, a geofence, if you will, reject geofence. Everybody, please stay out of this area. To everybody, within 10 seconds or less, all the controllers in the area will get this data. will update the missions of the drones, and now the drones will execute the new mission and leave the area. Question is, of course, how does the USA get this, UAC, the authority, get this data? What is the user interface by which ATC or another entity will use to push these dynamic policy updates to the UACs? The answer is completely up to NSP. What we care about is not the internal implementation of how the UACs are implemented. What we care about is the standard protocols that allows these UACs to talk to each other. If the protocols are standard-based and everybody speaks the same language, just like we do on the internet today, your laptop can wake up in every country and connect to the internet, and you go to a website and it works on any browser, on any operating system. That is enabled through technical standards. If we implement the same technical standards, everybody can interoperate. That's very important. Okay, and I'll get you back to the original picture. This should make more sense now. We have my drones talking to my UAC, which is just infrastructure deployed on the internet. They speak to each other using vehicle-to-vehicle communications, which is just fancy way of saying Wi-Fi, which is exactly how new cars are talking to each other through V2V, V2X technologies. So DCRC is another set of technologies that you probably heard mentioned. They speak to my UAC, or your drones to UAC, through a controller-to-vehicle or vehicle-to-controller interface. That is work that's already being taking place. They speak to each other between UAC through a federated interface, and the protocol there is controller-to-controller. The same exact technical interface is between operators, the UACs, and the operator that is the authority, the ANSP. There is no technical difference between all of them. The one major difference is that this authority UAC has superpowers. You can do things that me as a UAC operator cannot. Call to action, and I'm almost done. If you're an authority, we have to adopt performance-based guidelines. This is important. The world is changing fast. Technology is evolving super fast. What we think is hard today will suddenly be easy in 2-3 years. If we specify the performance, we keep ourselves open to innovation. If we specify the technical standard where it's inappropriate, then we're locking ourselves to, basically what we have done in some places in other domains. So it's also important for the few cases where we actually do require technical standards, C2C, UAC to UAC, vehicle to vehicle. In these few places, we must implement technical standards. And your job will be to endorse and bless, if you will, these technical standards to ensure that all the parties speak the same language. The question is, what is the HTTP for drones? What is the TCP? What is the internet infrastructure for drones? That requires technical standards. If you're industry, that's me, I'm sort of pointing at myself in this case. We have to propose and implement these guidelines for interoperability. And we also have to implement in a certified way these technical standards. Just because we tell you that they're implemented correctly doesn't actually mean you should trust us, you, the authority. You should require certification and testing and compliance of these implementations. That's pretty standard in security software, and we expect that we'll use the same ideas here. I think we have an opportunity to build a safe and secure system from day one, and with this, I think I'm done. Yep, and thank you.
Thank you very much for our speakers this morning, and again, we're going to have some more this afternoon, and then we'll have everybody back up. We've got some questions, some good questions, so I look forward actually to the interactive part of this that we're going to get later, and I think Leslie, though, has a few words. So we'll see you guys at around 2:30.
Yes, but before anybody gets to go anywhere, I want to first off thank all of you. That was absolutely fascinating. So I'm glad we're all here. But before we could go to lunch, I do want to also bring up Olivier Rea from Thales. Thales has been sponsoring the lunch for today, so come up and have a quick chat with everybody.
Thank you. So, hello everybody. Sorry for my French accent. I will try to do the presentation quite quickly. Some of you have already seen it, but the audio will change compared to the last one. Do not be offended. I will read mainly my speech because first there is numerous Thales customers in this area. One Thales SVP, and I would like to keep my job, so I will read rather than having a full speech. So, where's the return? There. Perfect. US is growing at an incredible speed. Figures you see are also applicable to other parts of the world, whatever it's Europe, Asia, Africa. We can be pros or cons drones, but it's happening. There is no discussion on that. Restriction by regulation and conservatism would be swept away. Again, no doubt about it. Not because of a technology push from UAV, but because we think that UAV are supporting a societal change. Societal change are never blocked, neither by regulation nor by geography. We've seen from the presentation of Professor Huat from Ente on how drones are going to be deployed in high-density urban areas. We have also seen from Mrs. Cardi and Baldoni, but also from Ms. Muriel Pro yesterday, that some countries have decided to be at the forefront of the story. Why it's a societal change? Because US will contribute to reduce geographical discrepancies between citizens. That's the point. As said earlier by Timothy Reuters, US are used to deliver medicine and bloods to isolated areas. They are also used in the future to transfer organs from an hospital to another. And those examples are only little examples of what the drones will enable, not for our companies, but for us as citizens. If you think that US is only about another market opportunity, I'm sorry, but you miss the point. This is bigger like that, and you miss the big picture. When talking about the big picture, we have to stop to think on US against manned aviation, on UTM against ATC. That's a nonsense. UTM is a part of a holistic picture which is named airspace. So nature has been enough kind with us to not put barriers in the sky. Could be great if we can avoid to invent them. Segregation is not acceptable. Accommodation is only a very short-term view. What we have to target together is full integration of UAV in the airspace. On top of that, as I do hope all of you, I'm a taxpayer. And when we look together at the billions of dollars or euros invested in CSAR and next-gen programs to relieve the airspace segregation, creating a new airspace segregation for UAV or UTM is just a nonsense. The key objective of Thales when delivering UTM, counter-UAV or ATC solutions is to enable information sharing, operation coordinations, while addressing specificities of each market and stakeholders, whatever they are operators or authorities. What you see on Thales on the screen, is the Thales vision of UTM. It has been built by talking and exchanging with you, whatever you are regulators, US manufacturers, US operators, UTM providers, or citizens. Thales is engaged in working groups, standards body, rules-making policy groups, and discussion over the 6 continents. These principles have been emerged as key elements of an effective UTM solution. Each country may have different regulations and policies, but these principles appear for us as universal in nature. Enable safe, secure, and efficient professional and recreational US operation in all environments. We absolutely need to have an holistic approach when talking about UTM. Safety, security, and efficiency should be considered together and not in a separate manner. UTM playground is from rural to urban areas. It's not only for a part of the world. UTM system has to be trusted for all its stakeholders, so it does put an emphasis on cyber security. You also see recreational users in this sentence. it will be a nonsense to include a significant percentage of the US flying in the airspace just because they are hobbyists, except if we want to have non-accurate air situation and imprecise information delivered to the authority and to the professional users. Balanced responsibility between UTM and UAVs, depending upon UAV's performance capability. Not all UAVs will have the same performance. And that's fair enough. They will have the performance they require for the operations. So it's why we should consider the food chain from UTM to UAV. And both are complementary. When UAV has a, let's say, lower performance, UTM can increase that performance, that's ground services. When the UAV will have a high performance, the UTM services will not be so supportive because UAV will be more autonomous. Ensure coordination and deconfliction between manned and unmanned operations. Low altitude airspace is not empty. I was on vacation, part of France where there is no ATC traffic at all. But the airspace was overcrowded of VFR, helicopters, gyrocopters. The roles of the UTM will be to support this deconfliction, to keep a fair access to all the users. I repeat, a fair access to all the users. Intelligently leverages autonomy, both UTM and in the vehicle. No question about this point. It has been said also by Amazon. Identity of UAV's flight will be possible only with a high level of automation, both at the UTM side and at the UAV side. Organize and manage efficient use of uncontrolled airspace to deliver safety and security. Airspace management is key. Our UTM solution has not been designed as traditional control in the meaning of aviation, but as an orchestrator of UAS flows and airspace dynamic restructuring to cope with high density of drones and unexpected event management. Last point, deliver service at a price which is insignificant compared to the end user cost structures. This is key. Title of that conference is Drone Enable. Enabling means ensuring a fair access to the airspace for any operators which need it. Cost is a part of it. It does call for new and innovative business models that Thales is ready to support and invest for with motivated partners. Her roadmap is aligned with European New Space roadmap, with NASA and FAA roadmaps, as well as other major and key initiatives over the world. I kindly draw your attention on the fact that road blockers need to be solved for some UTM services, whatever it's about standardization, safety cases, or further R&D. But I think that this is why we're here together today. Identify the road blockers and push a roadmap to solve them. Without an adopt, UTM and UAVs will disrupt the aviation, but both have to learn from each other. UAV will learn from aviation and safety on safety and security. Aviation will learn from UAV's world on efficiency and autonomy. Because of our aviation history, our systems manage more than 40% of the worldwide airspace, and our massive investment in UTM, UAV, but also in autonomy, cybersecurity, we now run several security operations centers in the world, and artificial intelligence, Thales is delighted to be a swivel pin of this incredible story of UAV and UTM. Without any doubt, 2018 would be a great year for UTM. And I can already tell you that it will be a fantastic year for our UTM solutions, for our present and future partners. A few of you know our UTM team. We always welcome cooperations, partnerships, as we think that this is a too critical topic and urgent topic to be addressed only by a single company. Before I forget, news to say that if you want something done, do it yourself. So tomorrow I will talk on geofencing, registration and identification and panels, but I will not speak as Thales. I am honored to represent more than 200 companies with cumulated annual revenue exceeding 360 billion of euros during the conference of tomorrow. Now it's time for you to wake up, have a great lunch, enjoy those 2 fantastic days. Thank you for your patience.
Thank you, Olivier. All right, everyone, lunch. Please be back at 14:30, at 2:30, and we will continue with the UTM stream And then at the end of the UTM stream, we will have questions. That's when we'll open it all up. So, off to lunch. Thank you.